Hi, this is Mel. Today we're gonna go through chapter 20 of VCE Math Method Unit 1 and 2. And this is about differentiation of functions. So, a quick summary about this. For differentiation, a very common tool we can use is the chain rule. So the chain rule is often used to differentiate complicated functions by transforming it into two simply functions, which are chained together. And it gives us an example. For example, y equal to square root 3x power of 2 plus 1 can be transformed into y equal to square root of u. So instead of writing this whole 3x squared plus 1, we write u instead. So we let u equal to 3 times x squared plus 1. And then by differentiate dy dx, we can write it as dy du, then times du dx. So how can you remember this? It's very simple. If you just try to cancel the denominator du and numerator du, so you also have dy dx. That's a way to remember it. So here is the chain rule stated as this one. So back to this example, if we want to do dy dx, we can actually do dy du with this function and then du dx with this function. Okay, so let's move on. Using the function notation, the chain rule is stated as, so it's a composition of functions of f and g, where f of g x is equal to gx first, and then gx is in the place of x of function f. So for example, if we have fx equal to something like 2x plus 1, and then we have gx, for example, x squared plus 1, then this x over here represents the whole chunk of x squared plus 1. That's what the composition function means. And how do we differentiate this function? So it's very simple. We can differentiate this part and this part. So we differentiate gx and then times with f gx differentiate. So in here, is equal to plus 1, then plus 1. This differentiate times the differentiate of x squared plus 1 differentiate. And then you can solve it. And then let's move on to derivatives and antiderivative of powers. So the power one is the most common one of calculus, which you probably need to remember the function, the equation, the formula. So if we have fx equal to x power of r, and then the differentiate of fx is equal to r times x to the power of r minus 1. So it's like you move the r down and then minus the power part by 1. Note that for any non-zero rational number r, so r is any non-zero rational number. because if r is 0, then if fx, we have x to the power 0, which is just equal to 1. Then we have is equal to 0. That's for constant differentiation. And then backwards, if we want to integrate x to the power of r, then we have 1 over r plus 1, and then plus another term to the power of x. And then don't forget to plus c. That's very important. Do not forget to plus c. And this only works for any rational number where r is not equal to -1, because if r is equal to -1, then the denominator will be not defined. And always remember the differentiation, diff, and integration. Are like transfers. So if you diff something, you get, let's make it more clear. When you do diff, you get gx, and when you integrate gx, you get fx. Okay? So it's like a loop. If you take a diff of a function, and the function you receive, if you integrate it, you get the original function fx. So it's always useful if they want to, for example here, to calculate the integration, and you get a function, right? So how to check this answer to be correct or not? A simple way is to just differentiate the answer to see if you get the original function they want you to integrate. Then let's talk about second derivative. So you can have first derivative, second derivative, and third, fourth derivative. It's only about taking the derivative once or twice or triple time. And it's very, personally, I think it's very confusing, like where to write the two. If you have third derivative, then you might write it like this, and fourth derivative like this. So remember, the top one, you write the 2 just behind the d, and for the denominator, you write the 2 near x, okay? So don't be confused. Or we can just write it as this, f dash dash. So if we have, for example, fourth derivative, then more conveniently we'll write something like this. Okay, then let's talk about how to sketch graph. When we're sketching the graph of a function, consider the behavior of the function as x becomes larger positive and larger negative. So what it's saying is, if you have x-axis and like a y-axis, for example, let's have an exponential function. If x is approaching to negative infinity, which is large negative, then the function is approaching to 0, right? Approaching to 0. And what about large positive? If x is converging to infinity, positive infinity, then the function becomes infinity. So approach infinity as well. And we need to consider about the vertical asymptote. It's always important to consider about the asymptotes and intercepts, okay? For this one, we don't have an asymptote, but we have y-axis intercept, which is just 1 for exponential. And stationary point. So the definition of stationary point is the first diff is equal to 0. Or you can say the gradient is 0. So the first derivative actually represents the gradient. For example, in our graph of exponential, we can have, for example, at x equal to 0, we have a gradient like this. And this line actually represents the derivative at this point. So if the derivative is 0, or in other case, you can say the gradient is 0, which is just flat, okay? If you have a tangent, which is flat, then you have a stationary point. Here are some cases for that. For example, we have a curve like this, and you have a tangent at this point, for example, 1, x is equal to 1, and you have the tangent, which is horizontal, then that means the derivative at this point is 0, which means x equal to 1 is a stationary point. This is called local minimum. And we also can have a local maximum, which also corresponds to a stationary point. Or we can have a point of inflection. Point of reflection. Okay, so something like this. So it's increasing and then increasing, or you can have, oh, this is not good. Something like this, decreasing and then decreasing. So it's about the speed of decreasing, which relates to second order derivative. And you'll learn that in Unit 3 and 4. So yeah, the stationary points are very important for Unit 1 and 2. And for this chapter, you need to remember the chain rule, the derivative and antiderivative of powers, and how you want to sketch graphs. Okay, that's it for today, and hope you enjoy watching.